On a preserved computer printout from 1977, 6 characters represent one of the strangest signals ever detected from space. It lasted just 72 seconds and has never been heard again. On August 15, 1977, a radio telescope in Ohio detected something unusual. A strong radio signal rose out of the background noise, reached a peak, and then faded away. It seemed to come from a fixed point in the sky. It was concentrated into an unusually narrow range of radio frequencies, and it arrived close to the frequency associated with hydrogen, the most abundant element in the universe, and a part of the radio spectrum that scientists had long considered a logical place to listen for signals from another civilization. A few days later, volunteer astronomer Jerry Amon was reviewing the telescope's computer printout when he found the event. Next to a sequence of 6 characters, he drew a red circle and wrote one word in the margin: "Wow." Nearly half a century later, the name remains, and so does the central question. What produced the wow signal? Was it a rare natural event, interference from Earth, or something artificial, transmitted from somewhere beyond it? The signal was detected by the Ohio State University Radio Observatory, better known as Big Ear. Despite the name, Big Ear did not look much like the radio telescopes most of us picture today. There was no giant dish turning toward different parts of the sky. Instead, it used 2 enormous reflectors and a pair of receiving horns. The telescope stayed fixed while the rotation of the Earth carried different parts of the sky through its observing beam. That made Big Ear especially useful for surveying large areas of the sky. It did not send messages, it listened. More specifically, it searched for narrowband radio signals, signals concentrated into a very small range of frequencies. Most natural radio sources are spread across a wider range. A very narrow signal can therefore be interesting, although it is not automatically artificial. The technology was modest by modern standards. Measurements were processed by an IBM computer and printed on long sheets of paper. Every character on the page represented the strength of the radio energy measured in one frequency channel during a short interval. Most of those pages were exactly what the researchers expected: long stretches of ordinary background noise. Then came 6EQUJ5. It's tempting to look at 6EQUJ5 and imagine it was an encoded message of some sort. But it wasn't a code at all. These were 6 measurements of signal strength. Big Ear's computer used numbers for lower values and letters for higher ones, so in this system, 6EQUJ5 represents approximate signal-to-noise values of 6, 14, 26, 30, 19, and 5. Read from left to right, the signal grows stronger, reaches a peak, and then fades. That shape is important. It matters because Big Ear did not track objects across the sky. The telescope stayed fixed while Earth's rotation carried the sky through its observing beam. A distant point source should therefore rise, peak near the center of the beam, and fall away, exactly like the wow signal did. This, of course, does not prove that the signal was artificial. It does not even prove that it came from deep space. But it does tell us that the event behaved much more like a source moving through the telescope's view than a random electronic glitch. Each printed character represented roughly 12 seconds of observing time. 6 measurements gave researchers the famous 72-second duration. But that number was not arbitrary. 72 seconds was also about how long a point in the sky took to cross Big Ear's narrow beam. In other words, the signal was present for the entire time the telescope could see that direction. It may have begun before the source entered the beam. It may have continued after it left. The telescope could not tell. But that brings us to the first major problem. Big Ear had 2 nearby receiving beams. A steady celestial source should normally have appeared once, then appeared again a few minutes later as it crossed the second beam. However, the WOW signal only appeared once. So whatever produced it was not simply a permanent radio source sitting in the sky. It either switched off, changed strength dramatically, or was something more complicated than a steady transmitter. The signal also arrived close to 1,420 megahertz, the frequency typically associated with neutral hydrogen. Hydrogen is the most abundant element in the universe. Because any radio astronomer should recognize its frequency, some SETI researchers had suggested that this region of the spectrum might be a logical place for one civilization to attract the attention of another. That makes the frequency interesting, but not conclusive. Hydrogen exists naturally throughout the galaxy. Motion can shift the frequency we receive, and a signal near the hydrogen line does not become artificial simply because the location would also make sense for communication. So by this point, we have a strong, narrow signal with the shape of a source crossing the beam, appearing near a scientifically important frequency, but only once. Now we can ask which explanations actually fit those facts. The simplest possibility is interference from Earth. Earth is surrounded by radio transmissions. Broadcasts, radar, satellites, aircraft, military systems, electrical equipment, and accidental emissions. A terrestrial signal can even reflect from an object in space and appear to arrive from above. Jerry Amon, the astronomer who circled the printout and wrote "Wow," remained open to this explanation. Interference could explain why the event happened only once. But it also has to explain the signal's remarkably smooth rise and fall, its narrow frequency, and the way it matched the telescope's beam pattern. The frequency range was also protected for radio astronomy, although protected does not mean perfectly free of illegal, accidental, or reflected transmissions. However, no specific Earth-based transmitter has ever been identified. So, interference remains a possible explanation. But it's also incomplete. It only describes a category of causes, not the specific cause that was actually demonstrated. Several natural explanations have been proposed. The best known involved comets. Comets can release large clouds of hydrogen, and 2 were near the broader candidate region in 1977. Later observations reportedly found radio emission near the hydrogen frequency around one of them. But the comparison is not a clean match. Diffuse cometary hydrogen would usually be expected to produce weak, broad emission, not something as strong and narrow as the WOW signal. Astronomers also disputed the comet positions and the observing methods. The comet idea gave researchers something testable, but it did not solve the event. A newer proposal is more complicated, but it tries to explain several features at once. Researchers studying data from the Arecibo Observatory found much weaker narrowband signals that may have been associated with small clouds of cold hydrogen. They proposed that an intense burst from a compact object, possibly a magnetar, could briefly stimulate one of these clouds into producing a very bright, narrow radio flare. That could create a source fixed in the sky, strong for a short time, narrow in frequency, and rare enough never to repeat. But that mechanism has not been tied to the 1977 event. No exact hydrogen cloud has been confirmed. No matching magnetar burst was recorded, and this proposed process still needs stronger observational evidence. It is a plausible pathway, but not yet a solved case. Now we come to the possibility that made the WOW signal famous. Could it have been artificial? Some of its features are exactly the kinds of things SETI searches for. A strong narrowband signal, apparently arriving from the sky, near a frequency that could make sense as an interstellar meeting place. But none of those features belongs exclusively to artificial technology. Natural processes can produce concentrated radio emissions. Interference can imitate celestial signals. And the WOW signal contained no decoded message, no repeating pattern, and no information that identified an intelligent source. Most importantly, it never repeated. An extraterrestrial transmission cannot be completely excluded from the evidence, but it cannot be established by that evidence either. Calling it proof of alien intelligence, as some have, would require the printout to tell us something that it simply does not. So, where does that leave us? Big Ear recorded a very strong narrowband radio signal from the general direction of Sagittarius. Its strength rose and fell almost exactly as a point source should while crossing the telescope's beam. It appeared near the hydrogen line. It was detected in only one of the telescope's two beams, and despite repeated searches, it has never been conclusively found again. No transmitter on Earth has been identified as a source. No comet, hydrogen cloud, magnetar, or other astronomical source has been confirmed. And no extraterrestrial civilization has been connected to it. The most accurate conclusion is also the least dramatic. The WOW signal was a real and unusual observation, but its source remains unknown. That is exactly why the WOW signal still matters. Not because it proves extraterrestrial intelligence, but because it shows the difference between an extraordinary observation and an extraordinary conclusion. The observation was real. The excitement was reasonable. The possible explanations are worth testing. But one event, recorded by one instrument, without repetition, was never enough to identify the source. For 72 seconds, Big Ear detected something remarkable. Nearly 50 years later, the evidence still allows several possibilities, but confirms none of them. Uncertainty does not mean every explanation is equally likely. It means the investigation has reached the limit of what the surviving evidence can support. And until the signal returns, that is where the WOW signal remains, unexplained. But the investigation reminds us that uncertainty is not an invitation to believe whichever story we prefer. It is an invitation to keep looking.